Okay, so we are back for video 3, and here comes the title. It is ratios continued, basically, because we already started ratios in the previous video. We just did a little bit, tiny bit. Anyway, here we go. Okay, sorry about that. Ratios continued. It's also going to be proportions and variation. That's the plan. By the way, in your book, this is 6.2. Okay, let's get back to variations. Here's the question: what if you got a 2 point? You want to we want to compare. Let's we call problem number 2. Problem number 2. You want to compare a 2-foot board. All right, this is going to be, I think, fairly straightforward. I don't think you're going to, find this difficult, but you'll be the judge. 2-foot board to a 18-inch board. Okay, so now, if you wrote 2 to 18, that would be wrong. There's a problem here. They're not compatible. One's in feet and one's in inches. So what's the smartest thing to do? Right, 2 to 18, and then you turn that into 1/9. All of this would be no good. Okay, so what do we need? We need to convert either inches into feet or feet into inches. It's much more convenient to convert feet into inches. 12 inches each foot, so that is going to be 24 inches. That's one of the boards, compared to 18 inches. There's our ratio. Right, I could write inches over here, but I don't want to clutter. So you cannot give this as the final answer, because this is whenever you have a fraction that you can reduce, you must reduce. Whenever you can reduce, you must reduce. So this is divisible by 6, and this is divisible by 6. 24 divided by 6 is 4. 18 divided by 6 is 3, and that's the final ratio that you would give for a situation like this. Okay, now we go on to something a little bit more than that, than a ratio, but it's really two ratios compared to each other, which are proportions. So here's a way that you might see on ALEKS, or on the test that ALEKS gives, how they would depict a ratio: 4 to 7 with a little colon there. That's a perfectly good way of depicting a ratio. Another ratio that we could give over here is 8 to 14. Right, that's another way. That's a perfectly fine way to describe a ratio. Okay, now let's prove if these are equal or not. Right? Are these two ratios equal or not? Simple question. Okay, let's move the paper up right away and show you how that's done. This ratio can be converted right away into a fraction, and this ratio can be converted into a fraction, a over 14. And the question is, are they equal or not? We still don't know, right? We still don't know if they are equal, yes or no, if they are equal or not. All right, here's how you go test it. You might see right away that they're equal, but let me show you how to test it. You cross multiply the numerator on the left times the denominator on the right. What is 4 times 14? It is 56. Then that's the first cross multiplication. Put the number on the left. Then the other cross multiplication is the denominator on the left times the numerator on the right. 7 times 8. How much is that? 56. These numbers are exactly the same. Therefore, yes, right, these ratios are equal. This is a proportion comparing two ratios. Yes, these ratios are equal. I'm just going to write these are equal. And if they were just off by one number, just the tiniest bit of number, then you would say that they are not equal, right? So that's very, very important to write that they're, if they're not the same, you've got to write them as different. Okay, so now that is the story with this. Let us try a couple of these, right? The paper ran out. Fine, no problem. Let's go get another piece of paper. Close this one. Get another one. Here we go. And now let's try a few more. How about problem number, let's call it problem number 4. And let's try 2 of them. Let's say you've got 14 over 16 and 7 over 8. So is this a proportion? Is this proportion, and here's how you might get it on Alex or a test. Is this proportion true or false? Right? So it's very important. This is another way of writing it. Forget about my yes or no. This is more that you might have it that way. Don't forget about it. It might happen that way. But another way of them asking you the question is this proportion true or false? So if they're equal, it's true. If they're not equal, it's false. Right? So that's, be sure to, don't get caught up by don't get, basically mixed up by the vocabulary. So is this proportion true or false? If they're going to turn out to be equal, yes, that equal is tentative. We got to check that out. We don't know if they're equal. Let me go back and get my pen. Here we go. Sorry about that. I need my pen back. So hopefully they're giving it back to me. Yeah. 1 second. Sorry about this little a bit of a. Now I'm good. Apologize. Okay, so anyway, proportion true or false, right? So that this equal over here, what I was trying to point out before I got disturbed there, is that this equal is tentative. We don't know that yet. Is it true or false? So if they turn out to be, if the cross multiplication works out, you say true. If the cross multiplication does not work out, it's false. Let me show, that'll be 4a. And then when we finish with that, let's look at 4b. 4b, which is a different problem, which is the situation is 5 over 3 equals, and again, that equals is tentative. We don't know if that's true or not. Equals 7 over 2, so is this true or false, right? So the same exact type of problem, true or false. Fine. Let's get to work on this one. Cross multiply. 14 times 8, that's going to be 8 times 10 is 80. 8 times 4 is 32. So it's going to be 112. What is 16 times 7? 7 times 10 is 70. 7 times 6 is 42. So it's going to be another 112. And therefore, we pick the proportion is true. What about this one? Let's try this one. 5 times 2 is 10. 3 times 7 is 21. Not even close. Right? 5 times 2 is 10. 3 times 7 is 21. And we pick false. And that's how we deal with this stuff about proportions. Okay, next. That was problem 4a and 4b. Let's move up the paper. Again, trying to make sure that I don't go beneath the radar here when you try to look at the video, when you watch the video. Sometimes I can get a little bit underneath because it's not totally in line. Okay, that's a software problem, I guess, but it's my note. Solve the proportion for x. 12 over 48 equals 3 over x. In other words, find x. Well, it's obvious how we can do this. Cross multiplication. Right? You see a proportion like this, one of them is x, they want to know what x is, solve for x. Okay, if it says anything, it'll say solve or solve for x. Cross multiply, 12 times x is 12x. Let's be patient here. 48 times 3 is 3 times 40 is 120, 3 times 8 is 24. That would be 144. Okay, again, like since I'm running out of room, well, I can do this, divide by 12 on both sides because I'm looking for x. If I'm running out of room, I got to move over here. These two 12s cancel each other out. X equals 144 divided by 12. 144 divided by 12 is 12 itself, right? 12 squared is 144. This is a perfect square. Well, that's stuff from 105. Perfect square. It's something where it's a number which another number, a whole number, can be multiplied by itself and get back to 144. So that's a perfect square. Just a little reminders from 105. Anyway, for our purposes, we're done. We found out the answer to this proportion, x equals 12, and the problem is over. That's problem number 5. Okay, time for a new piece of paper. There we go. New piece of paper, clean piece of paper. And we continue with another proportion. What if it said as follows? This is problem number 6. It said x minus 5 over 10 is equal to x plus 2 over 20. Okay, so cross multiply. The numerator left times the denominator of right. So it's 20, I'm putting the 20 first, times x minus 5 is equal to my denominator of left times numerator of right, which will be 10 times x plus 2. We're looking for x, right? If it says anything, if they're giving us any instructions, they'll say solve or solve for x. Anyway, the right-hand side is 10 times x plus 2. Okay, let's get this going. 20, distribute the 20 across the parentheses. 20 times x is 20x. 20 times negative 5 is negative 100. Equals 10 times x is 10x. And 10 times 2 is 20. Okay, minus 10x on left and minus 10x on right. We got to get, if you have two x's in a linear equation, if I have x on both sides, you got to get rid of one of the x's. I usually pick on the smaller one. So I got to get rid of one of those x's, minus 10x, and minus 10x to compensate on the left-hand side. Whatever you do to the right, you do to the left, and vice versa. This is gone. Fine. This turns into 10x. 20x minus 10x is 10x minus 100 equals 20. Okay, now I need to be x isolated on the left, or right, but in this case left, preferably on the left, and get the numbers on the right. So I got to get this minus 100 out of there. How do I get rid of minus 100? Plus 100. Whatever you do to the left, you do to the right. I'm moving up the paper just to make sure. I don't want it to be off the screen. These are gone. We've got 10x is equal to 120. 20 and 100 is, of course, 120. Divide by 10 on left, divide by 10 on right. These are gone. And we get x is equal to, those two zeros cancel. 12 over 1 is 12. X equals 12. And we have problem number 6 done. X is equal to 12. Okay. So now we need to see something called a variance, right? So that's the last part of this. Something called variance. It's a little bit more complicated. All right. So now need a new piece of paper as usual. This might have to go on the next video. We'll see. But let's try to get what we can over here on this video. Okay, so we're talking about variance, the last topic of these three that belongs to 6.2. Anyway, here we go. As follows: if you have so if you have I got to give you a complicated sentence here. I'm going to have to actually do it on the next video because I ran out of time. We'll have to do variance on the next video. So it really is a timely fashion. We'll prepare for the next video.